So today we will do some questions from engineering sciences, fluid mechanics part, and we'll just cover everything, like all the topics. There will be some questions from most of the topics. But again, I'll just tell you guys that even in for mechanical, a lot of question comes from kinematics. So please give more attention to that part, and that part is actually relatively easier also. So that is good for us. So this is from GATE 2020. Let's first see this question, ME. The question is fluid number is a ratio of. So I think most of you guys would have studied this in your BE and
D, sir.
D. Yeah, exactly. So fluid number is a ratio of inertia to gravity forces. And so before going to the exam hall, I guess one thing you can do is keep these numbers and their definition in your mind. So I think these four numbers will suffice. So you have the Reynolds number, the typical Reynolds number, which we have been dealing with a lot in a lot of questions. So this is just the ratio of inertia force to viscous force, and this number you mostly encounter when you have some kind of pipe flow or flow or some kind of plate where basically viscosity can come in, and there is a formation of boundary layer, all those stuff. So that is your Reynolds number, and it's the expression for Reynolds number. Yeah, this is very well known by now, I guess. Then we also have Fluid's number, which was asked in this question. This is the ratio of inertia force to gravitational force. So this is used in open channel flows and flows over notches and weirs. So this is more relevant to people who do civil engineering, and this is the expression for the Fluid's number. Now Mach number also they can ask you sometimes. So this is the ratio of inertia force to elastic force, and this is used when you have very high speed flows, let's say in aviation and aerospace engineering. So this is given as the ratio of you can also consider it as the ratio of velocity of the flow divided by the velocity of sound in that medium where the flow is happening. So so this Mach number defines if the flow will be subsonic, sonic, or supersonic based on some values.
Sir, can Mach number be defined for a incompressible flow?
Uh, yeah, so no, I don't think so, because if the flow is incompressible, then there is no sound, right? I mean, in that medium. So sound can only travel when there are compressions and rarefications. So there is no Mach number for incompressible flows, basically.
Okay, sir.
Yeah. And then there is also Weber number, which is the ratio of inertia force to surface tension force. So where the flows where surface tension plays a major role, like flows on capillaries and tubes, there you might deal with Weber number. So just keep these things in mind. Maybe they can ask you a question about match, like four numbers with four ratios, and then you can do that. A simple 1 mark question. And then yeah, so this is from engineering sciences now. This also you must have done in your previous
Dynamic
course.
viscosity of gas increase, sir. Seems like
Yeah, so okay, there are multiple correct answers here. Tell me both the correct options, please.
AB.
Yeah, exactly. So for the gases, the dynamic viscosity increases as temperature increases, but for the liquids, the dynamic viscosity will decrease. Can someone tell me why that is the case?
For gases, sir, the randomness, the collision between the various gas molecules will increase, due to which viscosity increases. And
Yeah.
in case of liquid, वो expand करती है ना.
Mm, yeah. Yeah, I
मतलब
think
सर बॉन्डिंग डिस्टेंस जो मॉलिक्यूलर बॉन्डिंग डिस्टेंस ड्यू टू द इंक्रीज ऑफ मॉलिक्यूलर बॉन्डिंग डिस्टेंस.
yeah. So yeah, both of you are partially right. So for gases, this is perfectly fine. The viscosity is dominated by the interaction between the molecules, and as you increase the temperature, the randomness increases, and then there are more interactions between the molecules, causing the
For
viscosity to
liquid,
go up.
sir, for liquid, the force of attraction is
Exactly,
available.
yeah, yeah. So that's the word I was looking for. So for liquid, it's the force of attraction which governs the viscosity. But as you increase the temperature, this force of attraction decreases, and then this causes the dynamic viscosity to go down. So yeah, maybe they can. So this is like a very standard question when you have like your semester exams,
Sir,
but
pipe वाले क्वेश्चन नहीं बन पाते हैं.
pipe flow, I think we did it in one of the classes, Satyaman. I think you were not there. Maybe you can go through these slides and lectures. You'll find some of the pipe flow question.
Okay, sir.
Yeah.
Okay, sir.
Okay, let's see this one. So there are a lot of questions today. I'll go a little more quickly, and this is from again engineering sciences. A flow has velocity potential given by phi is equal to x cube, where a is some non-zero constant. Which of the following statement is are true about the flow? So there can be multiple correct answers again, and I think you have all the recipe of finding out the correct options. So yeah, please do it. And yeah,
Seems like A and D.
A and D. So what did you use, Abhijit, to solve this?
सर follow incompress में तो
Flow is incompressible. So what property will the fluid have, or the flow have, if it is incompressible?
Del dot rho v equal to 0.
Yeah. So here first you are given potential, right? So from velocity potential, first you have to go to velocity. So I guess that's the formula. U is given as this, and V is given as this, where phi is the potential. Now,
सर इसका B और D लग रहा है, A तो नहीं है लगता है.
yeah, I think yeah, Satyavan, you are right. So this flow is not incompressible because when you will do this, you will find that this is not equal to zero. Okay, we can just do this. So del u del x will be like double derivative of this with respect to x with a minus sign. So you will get some 6ax maybe. Yeah, so which is not equal to 0 for all x. So this is not an incompressible flow. But once you get u and v from here, you can actually try to calculate the curl of u, and this gives you okay the relative the vorticity. And if the vorticity is 0, that means the flow is irrotational basically. So that's what you should be looking for. So calculate u and v from the potential, and after calculating that you can calculate the curl of this velocity field. You will find that the vorticity is 0. So option B is right, that the flow is irrotational. And then this you can outrightly reject. Okay, this we saw was not right. This you can outrightly reject because there is no time dependence here. So the local acceleration is defined as this, where u is some velocity. So this will have again two components, partial u partial t and partial v partial t. So keep in mind that this u is your vector u. Maybe I should write it carefully. So this is your capital U, which is a vector, which will have two components, and these are the two components. But since there is no time dependence, there will be no local acceleration. Again, for convective acceleration, we know we have to find these two terms. So you need to find, yeah, just a minute. You need to find this. So this is the component in x direction, and this will be the component in y direction. And you will find that there will be some non-zero component in either x or y direction. This is okay. This is your local acceleration, and this is your convective acceleration. This is also called as advective acceleration. So you'll find that this is non-zero, and then option D will also be correct. This is clear, right? Abhijit, you get it, how we proceed with this right now?
Yes, sir.
Yeah, yeah. Okay. Yeah. So let's see this one now. Again, I want you guys to solve this. So this is a 10 kg mass placed on infinitely long horizontal massless flat platform is to be supported by a steady vertical water jet, as shown in the figure. The diameter of the jet is 5 centimeter. What minimum average velocity is required to hold the mass in place? And then they have given some properties of the flow. So density is given, g and pi is given, and they have asked us to neglect friction. So I think in one of the classes we had seen the formula of of the force exerted by the flow when it impinges a flat plate. That is the formula that you should be using here, and basically you need to balance it with the weight of this mass. So anyone remembers what the formula is?
Rho v square a.
Yeah, so that you get from impulse balance. And yeah, once I guess you know this, so yeah, this is your jet, and then it impinges on some kind of flat plate, and there is a momentum transfer, and you get the force to be rho a times v square, where a is the area of cross section and rho is the density of the flow. And then since here it balances the weight, you should be able to get the velocity. So please solve it and tell me what the final answer is.
Is it 7.14?
Yeah, I think you are right. Yeah, I think right, 7.14 is correct. Yeah. So did everyone get it?
सर ये जो फोर्स होता है उसका जे कंपोनेंट का क्या हुआ कंट्रोल वॉल्यूम में जो लग रहा है
What do you mean?
द रेडियल कंपोनेंट जो बाहर की तरफ पानी से निकल रहा है ऊपर
हाँ.
हाँ, इसकी वजह से मतलब ये भी तो कुछ रो वी स्क्वायर एरिया ऑफ द सिलेंड्रिकल जो कर्व सरफेस जो बन रहा है
No,
उसका भी
but
तो
this
कुछ
is perpendicular
मतलब
to the
ऑल
normal
डायरेक्शन
surface, right?
यस सर
So this will not really exert any force on the plate.
पर इसका कुछ कंसिडरेशन तो होगा ना
I mean, on the plate, you mean?
यस सर
No, not really. I mean, so then you can also think that there might be some frictional forces acting.
नो
Basically, it is a
सर आई वाज थिंकिंग दैट एज द डायरेक्शन ऑफ द angular direction of the momentum is changing, so force is being exerted, so initial direction was upward and the final direction was uh, मतलब x direction जो भी radially outward, so
yeah, but
उसका कुछ
but
consideration नहीं
when you get this formula, this is just for the force exerted on the plate in this direction, the horizontal direction. Maybe I can specify it here. And in this case, okay, this will be the force in the vertical direction, right? And that force balances your weight in the downward vertical direction, which is equal to mg.
Okay.
Yeah. So I think this will be some 7 point. What did you say, Suraj? What was the answer?
7.14.
Yeah, 7.14. Meter per second. Yeah, let's see this one now. So this is from, again, some sort of this actually comes from Bernoulli principle, but yeah, this is like using the pitot tube to calculate the velocity or the pressure drop. So they have given you this configuration where the flow is in this direction, and you are supposed to calculate the velocity of the flow provided that this depth of a different fluid is 20 mm. So this is your measuring fluid, which they call it as manometric fluid and has a specific gravity of 11. So we know what specific gravity is. It's the ratio of your original fluid to this fluid. So basically, if your original fluid has density 1000, then this manometric fluid will have density 11,000 kg per meter cube. And yeah, you are supposed to calculate this velocity. So does anyone know how we can do this?
Half rho v square equal to rho gh.
But what rho and what h? There
In
two
half
different.
rho in half rho v square we use 1000 kg per meter cube.
So what is that half rho av
और
square? Half rho v square.
सर ये फ्लो का जो वेलोसिटी का जो कंपोनेंट है.
Yeah, they call it the dynamic pressure basically.
यस सर, यस.
Yeah. Yeah, so I think Satyaman is right. But let's so in the end you can solve this. Maybe we should only be concerned with this formula at the end. So in the case of pettit tubes, the velocity of the flow is simply calculated as the pressure drop between the 2 points divided by rho, where rho is the fluid density, which is like the actual fluid density. So in this case, the flow is of water, or yeah, of some fluid which has 1000 kg per meter cube density. So that's the density we will use. And so only thing you need to know is how to calculate the pressure drop, and that I guess all of us know through hydrostatic balance. So we can simply say that this grad P will be rho g times this delta H, which is, so this has manometric fluid as the specific gravity 11. So this will be 11 into 10 raised to the power 3. Sorry, yeah. So just a minute.
सॉरी सर, इसमें फ्लूइड का भी rho gh ऐड होगा.
Yeah, you're right.
वो 300 mm जो है.
You can add that, or you can just, so it depends where you take the vertical section, right? Yeah, you can take it here. So for this fluid, it will be So yeah, let's just do it at this point, and at this point the pressure should be same, right? So one of them will have let's say we remove the atmospheric pressure for now, so this will be yeah some PA plus rho times rho of water, or rho 1 times G times 300 plus 20, whereas this one will have so okay this will have the same fluid, so rho 1 G 300 plus, now this has a different fluid, so this is rho 2 G 20.
Sir, here heights need to be taken in meter.
Yeah, sorry. So this will all be divided by 1000, and this also should be divided by 1000. So then you can calculate the delta P from this. I think this 300 will drop off. So P1 300 by 1000 will be cancelled with this term. And then this delta P will simply be your rho 2 minus rho 1 times G times oh, 20 by 1000. So this is 11 minus 1, and then you have this 10 raised to the power 3 for kg per meter cube. G they have asked us to take as 10, and then yeah, so I think this 1000 and this 1000 gets cancelled, so you get 10 into 10 into 20, or yeah, so this is delta P, and then once you know delta P, it's just, from the formula you can just say this will be 2 delta P over yeah, it should not be G, it should be rho actually, and rho should be the rho 1. This just means that this will be 2 times 2000 divided by 1000 square root. So this and this gets cancelled, and finally we'll get velocity to be 2 meter per second. So that will be the velocity coming from. So option A is correct.
Sir, that formula V is equal to under root something is
Yeah,
always valid.
yeah. For pitted tube it is, yes. This is for the case when the velocity measurement is being done by the pitted tube. This is your pitted tube here. Yeah. So then basically what it does is it constricts this flow from here, and from this you generate some kind of stagnation pressure, and so that stagnation pressure plus dynamic pressure is what gives you this formula here. But okay, we don't need to go into the detail. For the time being, just remember when you have an analysis of pitted tube, the velocity will be given by this expression. Yeah, let's just go to the next one. This I expect all of you to solve, because we have done so many questions of kinematics with similar kind of expressions. So just quickly solve this and tell me what the final answer is. And if someone does not know how to start, just let me know. I'll at least give you the formulas. I mean, I guess in one of the last slides we have already seen the formula, but still, if you guys want, I can help you with that. So please go slowly and make sure you don't make any mistakes, because here it's just a matter of calculations and you don't need to do much actually.
So
Just
should we apply Navier-Stokes theorem?
yeah, not Navier-Stokes, but you can, I guess, yeah. See,
Euler.
yeah, it's an inviscid fluid, so Navier-Stokes is not necessary here. Just use the Euler's equation. You are supposed to calculate the pressure gradient and the magnitude of pressure gradient.
I am not able to start, sir.
Oh, okay, no problem, Suraj. So yeah, it's fine. Thanks for asking. I'll tell you how to start this one. Maybe you were not present in one of the earlier classes. So we had seen that in the Euler's equation. So Euler's equation, you have, let's say you are in a two-dimensional world right now. So that's the case here. Your velocity field is 2D, and for me, let's say my this capital V vector is given by some u I cap. Oh, sorry, u I cap plus v j cap. So that's my velocity vector field. Now I can write the Euler's equation, which is just Newton's second law for the fluid, and it gives you that this velocity is just the pressure gradient force. So this will be, and similarly for V, this will be partial P partial Y. So this is your Euler's equation, and now this is called as the material derivative. And this we just saw in one of the previous slides how to break this down. This will be a sum of your local acceleration plus your advective acceleration, right? Because you are dealing with a fluid and not a solid, so you have advective effects coming in, and that is what makes this equation non-linear actually. But we don't have to go into that. We just say that this is your x momentum equation, and similarly you have your y momentum equation like this. So this is your y momentum equation. Now you will in this question you are being given u and v. See, if you see if u is dependent upon space and time, you can always calculate these partial differentials. It's just simply differentiating either with x, either with y, or with time. And on the right hand side, you have the pressure gradient. So pressure gradient will be just partial p partial x. So this is again a vector I cap plus partial p partial y
Sir,
j cap. Yeah,
in the y momentum equation, the second term is u.
yeah, yeah. So it's an advection, and advection will always be done by u and v, and it's the advection of v velocity. So this is v, this is v. So when you are in x momentum, the advection will be of u velocity, and when you are in y momentum, the advection will be of v velocity. So in x in the partials u will come, in y in partials v will come, and both will be multiplied with u and v outside. Okay. So yeah, then you have this as pressure gradient, and if they are asking you to calculate the magnitude of pressure gradient, then I guess you just do this, which is, I mean, this is like calculating the magnitude of a vector, which will be square plus partial p partial y square, right? So you have all the information. You just need to calculate the differentials and find the final
What
pressure gradient.
what is the answer, sir?
What did you get, Satyam?
5.657.
Yeah, this is right. So this was some 4 root 2, right?
Yes, sir.
Yeah, yeah. Good. 5.65, something like that. Priyanka, did you get it?
Same answer, sir.
Yeah, good.
Five.
Abhijit?
No, sir. I got something else.
Oh,
6 points.
yeah. You might have done some calculation error, but this method is clear, right? So this is straightforward, I
Yes,
think.
sir. Yes.
Yeah, yeah. Suraj, you can do it now because I think now you know what where to start and where to finish
Yes,
this.
sir.
Yeah, yeah. Yeah, so basically, okay, maybe one last thing I should tell you, Suraj. When you try to solve this, in the end you have to substitute for x, y, and t, because final answer should be in some numerical values. So here they have given you a condition that at 1 meter, 1 meter, and at time 1 second. So initially you will have this the pressure gradients in x, y, and t, and in the end you can just substitute this and then finally get the magnitude of pressure gradient. Okay, let's see this question now. So this is again a horizontal belt of negligible weight shown figure, and with steady velocity v of 2.5 meter per second skims over the top surface of an oil film of depth h is equal to 3 centimeter. The length L and width are given. Find the viscosity of the oil given that the minimum power required to move the belt is 100 watts. So how should we start in this one?
Shear stress.
Yeah, basically Newton's law of viscosity. So try to solve it, and yeah, if you again cannot start, just let me know. I'll give you some of the formulas and then you can start solving it basically. But I want all of you guys to like keep a pen and paper with you and solve it, because as I've been saying that practice is more important than knowing a lot of theory. So you just need to practice similar set of questions but again and again so that the mistakes are avoided. So please solve it, guys.
0.4.
Same answer.
Yeah, yeah, yeah.
Same answer.
Nice. Suraj, did you get it?
Solving, sir.
Yeah, yeah, okay. You can do this one. Let me know if someone gets an answer to this also.
Sir, is it 20?
Mm,
Three.
yeah, I think it should be 3, not 20. Yeah, Vijit. So what did you do, Vijit? Hello.
Hello,
Yeah, yeah, Vijit.
sir, am I audible?
Yeah, yeah,
Yeah, yeah.
you are. So what did you do? I was just asking you. How did you get 20?
Actually, actually, falling through medium of density, then I calculated in that way. I think I have made a mistake
Yeah, yeah, that could be the
by
case.
Second
using
answer.
terminal.
Suraj, what did you get?
3.
Yeah, yeah, okay. So yeah, answer should be 3. So it's basically what you have to do is just
By using terminal velocity, right, sir?
no, not really. You don't need to use terminal velocity. You just say that the weight of the ball is like this, mg, and then you have some kind of jet which impinges a impulse on the on the ball so that the ball just stays in the air. So that's all you need to do basically. So m dot is given to you. This is the mass flow rate, which is 0.01 kg per second. V is given to you, which is 3 meters per second. And let's see, yeah, G is given to you 10 meter per second square. So then I guess you just need to do the force balance and say that this, okay, maybe I should write m of the flow times velocity of the flow is equal to mass times gravity, and then yeah, that's m is what you are after, so this will be the mass of the ball, and that is zero point 0.01 times velocity, which is 3, and then you have g, which is 10, and then I guess they have asked you to calculate this in grams, so you can just multiply it with 1000 to get it in grams. So this will be 2 and 2, and then this will cancel. So mass of the ball finally will be 3 grams.
सर ये रो वी
The
स्क्वायर
V.
ये वाला फॉर्मूला ये जो बॉडी है उसके ये उसकी ज्योमेट्री पे डिपेंड नहीं करता.
It should actually depend, but I think here they are just taking this projection as flat. Yeah, this is like very idealized case.
I did say rho v square on terminal by using terminal velocity as well, so that I messed things up.
Okay. Yeah, yeah. Don't try to complicate things. If I think you can solve it through simple force balance, and no need to go into terminal velocity and all of that. I guess since this is supported against gravity, you should already get the hint that it is balanced by just the force of the jet. So terminal velocity is like velocity without any force, but it is coming down. It's not really coming down, it's just supported there. Yeah. Anyway, let's move on to this question. We have done a very similar question from GATE ME exam in one of the last classes. So this also I expect you guys to solve. And yeah, if you can solve it, just give me what the final answer is, and we can discuss this once everyone has solved it. So the setup is very simple here again. You have some big cylinder with the diameter d, and there is a small orifice at the end with a diameter small d, initially h1, which is given to you as 2 meters, is the height, and once the flow discharges from once flow starts exiting from the end, they are asking us to calculate the time t in which this h1 goes to h2, or basically from 2 meter you go to 1 meter height. So when it is halved. We solved something similar for ME exam where we used conservation of mass, and then we had to do an integration on some elemental dh to finally get the time it takes to go to any arbitrary h basically. So everyone knows how to start at least, right?
Yes, sir. But during the calculation time, should we apply the divergence as well, sir?
Divergence of what?
Rho and v.
Uh, Rho and V. I don't think you have to do that.
सर एक रफ एस्टिमेट 9.26 सेकंड आ रहा है.
I think that is not right. 9.26. Yeah, no, I don't think that's the right one. Anyone else? So you can assume that the density is constant. And
Yes, sir.
yeah. Please take density as constant. Unless stated otherwise, always take density as constant. At least for problems in gate ME. Priyanka, did you get something?
Doing so.
Okay. What about you, Suraj?
So
सर
DM
18.52 सेकंड.
Just a minute. Satyaman, yeah, can you go again?
18.52
Yeah,
seconds.
I think this is correct. Yeah.
2 से मल्टीप्लाई करना थोड़ा भूल.
Yeah, this is fine. What about you, Suraj? Did you get something or you are solving?
Sir, I started with dm by dt is equal to m in minus m exit,
Yeah,
and
exactly. Yeah,
while integrating
yeah.
means on one side I put volume of that liquid displaced,
Hmm.
and on other side on while integrating, uh, what to take v, is it constant or it is changing?
Mm, okay, yeah. So it is not constant. Yeah, let me take a new slide here. This will be the last question for the day, by the way. Yeah, maybe copy this also. So it will be dependent upon the fluid on top, the height of the fluid on top, and that velocity. I think you are referring to this exit velocity, right?
Yes.
Yeah. So this you can take as your root 2g times h, where h is the height above it. So this also changes with time. So basically you have this m dot in minus m dot out, which is the rate of change of mass inside your water tank. And okay, this anyway goes to zero because there is no inlet here, just outlet. And this outlet is your rho times this area. Let's call this as A out. So this is small a o times V. And this V you can actually through Bernoulli's principle show that this V is just root 2 G times H. So now you have M out, and for this dm dt you can take some elemental area and then say that this dm dt is nothing but d dt of rho times the, let's call this as A, capital A, times your, let's say this is your H. So this will be your volume, right? So area times volume, and this density gives you the mass. Then since H is changing, you can just take rho A out, and this becomes dH dt is equal to minus of rho A naught root 2 GH, and then it's just a matter of integrating. So keep this formulation in mind. Maybe they can switch in the question saying instead of H2 being at half of this H1 height, they can take 3 by 4, 1 by 4, 2 by 4. That all depends upon the limit of integration. Maybe we can just cancel the rows first and just say that A over A naught dH over root H, and there will be 1 by minus of 1 by root 2g is equal to dt. Now you integrate. Now you integrate the both sides. So this goes from time 0 till time, our specified time, which we actually want to calculate. And h goes from h1 to h2. So for us, in this case, h2 is 1 meter and h1 is 2 meters. So depth is decreasing, and that's why this minus will turn into a plus, because in the end time has to be positive. So okay, you can take 1 by root 2 times 10 outside the integration. A by A naught is also taken outside the integration. So A will be pi by 4. Yeah, this should be, okay, sorry, this should be small a actually. Oh yeah, no, not this one. Yeah, this should be small a naught, and this should be just a minute. Yeah, I might be, yeah. So this will be capital A and this will be small a naught. So this becomes pi by 4, and the diameter of this capital, the big tank is 1 meter. So pi by 4, 1 square divided by pi by 4. This is 10 centimeters, the small a naught, diameter of this small area. So we can just say 10 centimeter is 0.1 meters square. This and this again gets cancelled. And when you integrate dh over root h, you will get root h over 1 by 2. So I think Satyavan, you missed this 1 by 2 while giving the final answer. So this goes from 2 to 1. These are the limit of integration, and this goes from t. So this dt will be t, which goes from 0 till t. And then you can, I guess, finally calculate everything. So t will be your root 1 minus root 2 basically. So minus, that's how the minus goes away. 1 minus root 2, which is negative, and there is one negative sign on top of it. And this is multiplied with 2, so this is that 2. 0.1 square is what, 0.01, right? So 0.01 is 100 on top, 100 on top, and then you have root 20 in the denominator, and I think this should be equal to 18.5 maybe. So 1 minus root 2 into minus 1. Yeah, this is correct. So that's your final answer, 18.5 something, 52 seconds. Yeah. So, by the way, when solving these questions, please try to do it using your Gate Scientific Calculator, because you should be getting used to that also. But anyway, this is clear, right?
Yes, sir. Yes, sir.
Okay. Yeah. Yeah. So I think I have run out of questions for today. That's all I put in the slides. Maybe we went a little too fast, but that is because you guys solved a lot of questions quickly. So from my end, I think that's all I had. If you guys have any doubts, you can ask me, or anything you want to just talk about. That is fine with me. We have some 5 minutes.
I took J9.81. I got 18.7.
18.7 is, so I think the range was from 17.5 till 18.5, but I would advise you to please not do that. If they have written 10, you just take it as 10, because you don't know when they like cut down on this upper and lower limit of the answer, no? And they calculated using 10 only, if they have written 10 in the question. So try to make sure that you use whatever they have used. Yeah.
Sir, in that ball question,
Yeah.
that momentum integral equation means, what is the principal momentum integral equation?
So okay, principal momentum integral question is basically what they do to solve the. So maybe we have this example of plate, right, where we had the plate, and what happens is when this jet impinges onto this plate, suddenly the momentum in this direction stops. So you cannot have penetration through the plate, and so this momentum has to be suddenly transferred into other directions, let's say to the y direction. That's what I think Satyaman was also referring to. So in the x direction, you can use this impulse momentum equation, where you say that rate of change of momentum is in a short interval is the impulse, or the force, and from there you derive that initial momentum is some m dot v, final momentum is your 0. So then the rate of change of momentum is m dot v, and that is your force basically, and that's how you get this rho a v square. So m dot becomes rho a v, and then you have additional v coming in, so that makes it rho a v square.
No, sir, that jet and ball question.
Yeah. And the same principle will apply here also. So because in this direction, in the periphery of this spherical ball, there will be zero momentum at just at the periphery of the ball, because they say spherical ball is steadily supported, right? So you can think of it as again a flat plate which is being impinged by this jet, and instead of having the plate being fixed, we have the gravity of the or the weight of the ball acting as make trying to make it fixed basically. So that's how you get this force balance between mg going down and m dot v going up. M dot v is the rate of change of momentum here. So it's the same principle which applies in case of the flat plate. Yeah.
So ball there, it was initial momentum.
No, no ball. Forget about the ball. We are just talking about jet. So at the start, the jet had a momentum of m dot v. At the end, since now it has impinged on the ball and it has lost its momentum and given all its momentum to the ball, its final momentum is zero, and all the momentum has been imparted to the ball. And this momentum is trying to make sure that the ball does not fall under gravity. So that momentum balances the gravity force, and that's how you get this m dot v is equal to m of ball times g.
So means we are analyzing from side of jet. So we are taking
Yeah, yeah,
initial momentum minus final. So we are
yeah,
getting the loss in momentum.
yeah, 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 yeah,
Okay.
yeah. Yeah. Any other questions?
Sir,
Yeah, Vijay.
within this short period of time, what should be the strategy? Like few things I'm like losing grip on during
So I think what you have some
it's only
15 days or so, right?
20
Yes.
around 18
Yeah,
days.
yeah. Let's say just 15. I think the only strategy for for now is to give practice exams and revise your formulas. That's all. Practice exam and formulas, and every exam you give, you will encounter some formulas. Write them down, and
Mhm.
keep on memorizing them, because in the end, see, you see all these questions today we did. I think the last one where we had to do integration was a little tricky, and rest of them were like simple based on formula. So that's why I want you guys to solve as many questions as you can, so that you get to know of all the formulas that are being used. And then you have to memorize those formulas. That's all you need to do in these last 10, 15 days.
Hmm.
Yeah. So you should have started the practice test series by now. If you have not, please still do it. At least give 5, 6 full length test also, so that you know that how you are doing in terms of time, if you are able to finish everything in 30 minutes, oh sorry, 3 hours, and how much time do you have to give to aptitude, how much time do you have to give to math section. So all these things you should already have in mind when you go to the exam hall, because time management is also very important. See, right now you will feel that okay, you will be able to finish, but in the exam, let's say you get stuck in a couple of questions, then that pressure
Yes,
comes, and because of that pressure, you start making very silly mistakes. Like you,
yes, sir.
yeah.
That's what happening with me because after attending state series, I got one from one test is I got minus 2.37 and from one I got 12. Due to that reason, like while I'm attending class, like everything is going smoothly actually as
Mm-hmm.
like things like yeah I can contemplate that which formula should I apply or what it would be.
Yeah.
But while I attending tests is didn't I didn't get as such clues like what should I apply for, like as we are doing that topic wise, so
Mm-hmm.
that
Yeah, yeah, yeah. No, see, that's the thing. So it will be tricky there. So there you will have one question from fluid, then some question from math, and suddenly you will get a question from heat transfer. So that's why
yeah.
I would
Huh.
say just keep on practicing. Don't worry about the numbers you get right now. I mean, it's not the final exam. It's just for you to practice. And every exam you take, always look at the mistakes you are making. So let's say you got 12 in one exam. please
Mhm.
see the solution and see what you have been doing wrong. Because if you don't get this feedback from like the solutions, then you are not really improving. You are just giving exam.
Yes,
That's
that's
not the
what I
whole
did.
point. Yeah.
Yeah, that's what I did. But like covering all the things up like that is like seems like bit hectic and horrendous.
Yeah, it is hectic. So the syllabus is big, but there is no other choice, right? So still there are
Sir, after
15 days. You
uh,
have to somehow, I mean, at least cover all the main topics.
sir, if you don't mind, may I ask you one question?
Yeah, sure.
Did you secured in on your first attempt, sir?
Yeah, yeah. It's okay. I mean, don't think about first and second attempt right now. Just give your best in this attempt. Yeah, you can worry about the result once you are already done with the exam. For now, just practice and focus on the final exam. You can worry about the second attempt, third attempt, or any attempt afterwards. So I don't think you should think about that right now. Yeah,
Thank you, sir. Thanks for your valuable
yeah,
comments.
sure. Yeah, and yeah. By the way, I'll tell you guys that even if you don't get a very high score, there are options. So you should also be looking at those. So there are options of MTech research in IITs and ISC, which you can get for not a very high gate score. And then there are admissions that happen during winters also. So there are a lot of things like that, but that you can worry about later. I would say just try to give your best for the exam. Yeah. Okay. I think
Okay, even IIT and IIS take winter in intake as well, right, sir?
yeah, yeah, they do.
And what are those criteria? Like, for instance, if you can be
Yeah, same thing. I think gate score you have to have some kind of gate score, and there will be some cutoff, and then they will call you for interviews.
okay.
So, but the gate score cutoff for winter interviews are much lower than what it is for like the regular intake, the summer ones.
I mean, like, what is the? I mean, in as per your assumptions.
I don't remember right now. I mean, for last 3 4 years I have not checked, so I can't tell you. You can find it on internet. I think everything will be there. Yeah, but it's significantly lower than what you need in the summer intakes that I'll tell you. Yeah,
Okay, sir. Thank you, sir.
yeah, sure. Yeah, I think I don't have anything much to add after this. If no one has any doubts, I'll just say all the best with your preparation, and I hope you guys have a nice weekend also.
So
Thank
now
you.
weekends are not going nice.
It's okay, it's okay. Abhijit, only 3 more weekends and then it's done. So please try to stay focused and try to study.
Thank you, sir.
Yeah.
Thank you.
Okay.
Thank you, sir.
Yeah. Okay. Bye bye. All the best, guys.
Bye. Sir.